So next up, it's the turn of Victoria Sanz Fernandez, and she's going to talk about how to optimize hindgut health. Victoria, take it away.
Thank you very much. So this first slide is just to summarize a lot of the things we've been talking about during this webinar regarding intestinal health. So the intestine is a very sensitive organ, and there are multiple factors that can have a negative effect on it. And a lot of these factors accumulate during the transition period. When we have issues in the intestine, we might get leaky gut, and from there, inflammation and excessive inflammation. And as Lance has just explained, inflammation is indeed an issue associated with problems in performance, but also associated with the incidence of diseases. But today what we want to do is to focus on the hindgut. And the first point I would like to make is that similar processes occur in the rumen and the hindgut. And for this, I'll be using the abrupt introduction of lactation rations and the development of acidosis as an example, just because it's one of the factors that has been the most studied in ruminants. So again, this is repetition from what we've been discussing. These rations are characterized by having a large amount of grain and a high starch content. This is a known risk factor for the development of acidosis and leaky gut in the rumen. But we should not forget that these are associated with a large fraction of bypass starch that reach the hindgut, and here we can also have acidosis and leaky gut. This is well illustrated by this study. This comes from the Plaisir lab in Canada. Here they used two treatments. So they had control cows in a 70% forage diet. Those are represented by the blue bars in the graphs. And then they had animals in the diet intended to induce subacute ruminal acidosis. These ones had a little bit over 35% forage. And then they also had a pellet with wheat and barley. Those are represented by the green bar in the graphs. So first, looking at the rumen, we see that those high-grain diets actually did the job. They decreased pH and they increased LPS. What's interesting about this study is that we see a very similar picture as we go along the intestine, the gastrointestinal tract. So we see the same in cecum, so the beginning of the hindgut, and even in feces. And this is likely due to this high bypass starch we were talking about. Now, these two factors, the low pH and high LPS, were mimicked in this other study. This is an in vitro one, so this is done in the lab. Tissue from the animals is taken, and it's placed in an apparatus like this one. This is called a Using chamber. And this allows us to measure intestinal permeability. So it gives an indication of leaky gut. So in these graphs, it shows how they expose the tissue to different levels of pH, being the lower pH here on the left, and then the absence or the presence of LPS. So the black bar represents the presence of LPS. And you can see that for the rumen, the combination of low pH and high LPS, as we saw before, increases permeability, so we might conclude that there was leaky gut here. What's interesting is like when we look at the colon, we see exactly the same response. So these acidotic conditions increase intestinal permeability similarly between the both sides. Acidosis also induces damage at the microscopic level, and it does it both in the rumen and in the hindgut. So here we have the rumen pictures. On the left, control animals on a high forage diet. On the right, animals on a high concentrate diet. And these are pictures of the rumen papillae. And you can see that with the high concentrate, we start seeing the sloughing of the cells and detaching of some of the layers of that papillae. When we look at the hindgut, we get a very similar picture. So within the control diets, this is how a healthy intestine looks. As soon as we introduce the high-grain diets, we see that we lose the architecture, so there's a sloughing of the cells. And in the electron microscopy images with the red arrow, we see that the tight junction complexes are also suffering. So these changes actually not only occur at the microscopic level, we also see them at the macroscopic level. And it's not so uncommon to see at the slaughterhouse rumens like this. where there is hyperkeratosis, where there are lesions, where the papillae actually disappeared. It's a lot more difficult to find pictures from the hindgut just because people are not looking at it. But if we think of the mucin casts, this is actually a response of the body to damage. And the size of them, in this case, for example, almost 10 centimeters, will tell you that there is a lesion in the intestine of a similar size. So probably if we could take a picture of those, we would see also large regions of lesions. So we see that in both sides, similar processes occur, but actually we have indications of the hindgut being more vulnerable to acidosis, for example. And this is based on different factors. The first one is the structural one. So the rumen has a stratified epithelium that seems to protect it from acidosis. In the hindgut, we only have a single cell lining, which might be more, again, vulnerable. We also have differences in buffering capacity. In the rumen, we have the saliva, the protozoa, and these are important at modulating rumen pH. These don't exist in the hindgut. What we have in the hindgut is a mucus layer. And this might seem protective at first sight, but what the mucus layer is going to do is to create a microclimate here that it's going to avoid that the epithelium could sense changes in pH of the digesta. So it's really not going to be able to respond as well to these changes in pH compared to the rumen, which is in direct contact with the digesta. And the last difference is in immunity. And this is a little bit controversial, but it's kind of accepted that immunity in the rumen is attenuated, while in the hindgut it's a lot more robust. There are a lot more immune cells in there. In the next couple of slides, I'm going to show some of the work we've been doing in-house, trying to develop a model of hindgut acidosis and see how this leads to leaky gut and systemic consequences. So for this, we used 4 animals only. These were rumen fistulated animals, and we exposed all of them to 2 different treatments. The first one was a controlled treatment, and for this, we infused saline directly into the abomasum. So these would reach then the small intestine and the hindgut, and we would leave the rumen totally alone. The second treatment was a hindgut acidosis-inducing treatment. In this case, what we did is the same abomasal infusion, but at this time, what we put in there was cornstarch. Again, this cornstarch would reach abomasum, small intestine, hindgut. It would leave the rumen. This is the experimental schematic of that experiment. We had 2 periods, the saline one. Here we took our baseline measurements. We gave a break to the cows for a few days, and then we did our starch infusion, and we took actually our challenge measurements then. We were actually quite successful at inducing hindgut acidosis. This is shown in this graph. So the first one is the amount of starch we found in feces, and the green line is going to represent the starch period. So as you can see, there is quite a bit of variation because it was only 4 cows, but we very consistently increased the amount of starch in feces by infusing the cornstarch. Associated with this, we see the decrease in fecal pH that we expected due to increased fermentation. Now, we also measured the amount of alkaline phosphatase activity in feces. Alkaline phosphatase is a brush border enzyme. So the idea is that if we start seeing it in feces, it means there is damage of the intestine and sloughing of the cells. And similar to what we saw in the previous graphs, as soon as we start infusing the starch, fecal alkaline phosphatase increases, representing a certain degree of damage of the intestine. We also measured blood dilactate. Dilactate is the result of bacterial metabolism. So mammalian cells produce very little dilactate and metabolize very little dilactate. And the fact that we are seeing it in blood represents 2 things. First of all, that there was increased proliferation in the hindgut. And second, that this dilactate was actually leaking from the lumen of the intestine to the blood. So indeed, it seems like when we have hindgut acidosis, we are able to induce this leaky gut, and we are able to see systemic effects after it. Now, what can we do about it? We really think that targeting the hindgut with different strategies represents a window of opportunity. Definitely, we should not forget about the rumen, but maybe thinking about the hindgut will give us this extra help to improve health and performance. There are a lot of things we can do from a management point of view. Basically, anything fixing rumen acidosis will help with hindgut acidosis. But today I want to focus more on the nutritional strategies. In general, for gut health, nutritional solutions are well positioned because you have this intimate relationship. It's really in close contact. But then in ruminants, we have to keep in mind additional considerations, and this is the utilizing rumen bypass technologies if we really want to reach the hindgut. I would like to say that we are not inventing this. Actually, in non-ruminants, it's basically when you talk about improving gut health, you're by default talking about hindgut health most of the time. It could be the small intestine too, but when you use prebiotics, probiotics in humans, in chickens, in pigs, you're actually using them to treat your large intestine. So we cannot take the credit for this. And then I don't want to go through a long list of interventions either. I would just touch in a few components to highlight some of them. The first one is minerals, and probably zinc is the one that has been the best studied in terms of gut health, showing benefits in a lot of species, in a lot of models. There are environmental concerns with supplementing minerals to farm animals because of increased excretion. And the thing we can think about is mineral source, so organic versus inorganic. First of all, from an availability point of view, but even more important from a toxicity point of view, because we know that certain forms of inorganic minerals are going to be toxic, actually toxic for our intestinal cells. Probiotics, these are live microorganisms, again, showing benefits in other species. When we think about the hindgut, it's tricky because we need to get these microorganisms alive and viable to this section. So it, again, with the bypass technologies, the rumen bypass technologies, it becomes trickier to use them. Prebiotics, on the other hand, these are non-digestible compounds, and we think that this could be a good option to reach this section of the intestine. And they're better suited for these rumen bypass applications. We've been, in our group, in the R&D group at Tron Nutrition, we've been doing a lot of work with a specific one, and this is calcium gluconate. The background on this compound, it actually comes from swine. It was shown that feeding gluconic acid and gluconate salts improve performance in swine. So the initial experiments that were done, they were led by John Dulman back in Canada, were done with the unprotected molecule through abomasal infusion, similar to what we did in the hindgut acidosis model. And what they saw, and this is represented in this first graph, is that by giving these post-ruminally, there was a milk fat response. So milk fat was increasing. The next thing they did is to feed this product unprotected. So this was reaching the rumen and being utilized in the rumen. And there they were losing the response, demonstrating that this is really a hindgut response. From there, we developed a product that is rumen protected. This is thanks to a matrix of hydrogenated fat. And this allows the gluconate to reach the hindgut. And now we've done a number of studies that are summarized in this graph with this product and seems to have a positive effect on performance. So here we see the change in energy-corrected milk in the animals that are supplemented compared to controls. Each of the bars is a different study, and here we have a lot of studies, very heterogeneous. So some are in our facilities, some in universities, some in commercial farms. We see a somewhat variable response, which is kind of expected from this type of product and the mechanism of action, but overall a positive trend. So this is really is telling us that this is a feasible strategy to improve, to support hindgut health first, and from there to improve performance and maybe overall health. So this is already my conclusions slide. The first point I wanted to make is like very similar processes occur in the rumen and in the hindgut. And this is true for acidosis in response to high-grain diets. The hindgut actually might be more vulnerable to these acidotic insults because of the factors we discussed. The relative contribution of the hindgut to the systemic consequences of acidosis is still unknown, so we don't know exactly how much we can account for when it comes to the hindgut. And finally, it seems like targeting the hindgut with certain mitigation strategies represents a window of opportunity to further improve what we've done already by supporting the rumen. And with this, I would like to thank you for your attention, and I'm ready to take any questions you may have.
Thank you, Victoria. And as Victoria says, please keep your questions coming. She's joining us at the table now to answer some of the questions we've already had in. And the first one, Victoria, is from Jim, who asks, is there an optimal level of bypass starch for the high-performing cow to help avoid hindgut acidosis?
Yeah, that's an interesting question. I don't think we have the data really to set thresholds at this point. We might go to the extremes, but what's in the middle, we don't know. We also have a feeling that, there, like with a lot of these things, there is a large individual variability. So again, like Lance explained with hypocalcemia, the hyperketonemia, one threshold might not fit every cow.
Okay, but going back to that point, I believe today sources of starch are mainly selected on the basis of price, of cost. But if I were to ask you to rank them on the risk level for hindgut acidosis, which sources of starch would you typically avoid, and which sources would you typically be in favor of?
Yeah, well, this is a little bit out of my comfort zone, the more practical approach to these things. But definitely the type of grain, it's going to determine how much starch gets used in the rumen, how much bypasses. So in general, things like wheat and barley will be more digested in the rumen, corn will be more bypassed. But this being said, there is a certain level of starch that doesn't matter what you're feeding specifically, you will still get to the threshold of the rumen, and you will still get a large amount of starch bypassing it. So yeah, there are certain things you can do to manipulate in terms of management, but still, I think we're always going to have this large fraction of bypass starch in the lactation rations.
Okay, thank you. A question came in from Pavel, who says, do you think that fecal pH might be a farm and practical indicator of starch digestibility? Yeah, it's tricky. This is the million-dollar question. What can we monitor? What do we measure? The fecal pH, fecal starch. Again, in these very controlled studies where we take pH measurements frequently on the same cow, we are able to detect these fluctuations. As soon as we go to an on-farm setting where you might take one measurement, maybe the whole herd will give you an idea, but it's not. Except for very extreme cases, I don't think we're going to be able to pinpoint to the specific cow that has hindgut acidosis based on fecal pH. Okay, we've just had a question in from James, who's asking, is there a minimum level of butterfat in milk for a healthy hindgut?
Yeah, again, this is another one a little bit outside my comfort zone. Yeah, I wouldn't dare giving exact numbers about this one, to be honest with you. Yeah.
Okay. Carol asks, can you improve the hindgut with organic acids in the water to a pH of 4?
I'm not so familiar with organic acids, to be honest. Yeah, whatever I'm saying would be pure speculation. Okay. Yeah, there are different things that are being tried, and if it works in the rumen and then it reaches the hindgut, it should help there too.
But yeah, I don't feel comfortable giving any specific opinion for this because I don't know enough.
Okay, some tough questions for you. Sarah asks, what are your thoughts on rumen bypass glucose? Could this cause hindgut problems or would it help?
That's an interesting one, and one we're thinking in the group quite a bit lately. Once you have bypass glucose, you depend on absorption capacity of the cow, and in the small intestine, obviously, because most of it you would assume it's absorbed in the small intestine. There's some data out there, but I don't think we have a clear idea from a physiology point of view of the exact capacity of cows to metabolize the starch in the small intestine, absorb glucose in the small intestine. There is a lot of information we're lacking, and we go a lot by monogastric literature. So that's a good question. I mean, in principle, yeah, you get more glucose there, it's absorbed. You shouldn't be getting so much in the hindgut. But again, the proportions and the relative amounts, I don't think are well understood.
Okay, thank you. One question here. Can we use the manure score to check if a cow is suffering from hindgut acidosis? And what are typical manure aspects suggestive of hindgut acidosis?
Yeah, so that's a good question as well. Manure score, it's actually fully representative of what's happening in the hindgut. So the hindgut is going to be responsible for the amount of dry matter and water in feces. So indeed, if you have loose feces, something is going on at the hindgut. So indeed, it's a good marker of issues. But again, the tricky part is to establish the threshold. It gives you a general idea in the barn, but to use it as diagnostics for a single cow, it needs to be quite extreme.
Okay, super.
And what about this relation between problems and feed deprivation? Do you believe the hindgut plays a role there, or is that through another mechanism?
Between feed deprivation and what, sorry?
And problems.
Oh, yeah. Well, this ties to the inflammation story. Feed deprivation is bad for the intestine. We quite clearly know that. In ruminants, most of the time people have been looking at the rumen, but for sure the small intestine and the hindgut suffer from that. Because in pigs, in monogastrics, we see how bad feed restriction is. So I'm sure feed restriction will induce leaky gut, not only in the rumen, but also in the hindgut, and there will be inflammation coming from the hindgut. As we said, we think this might be substantial. We still are not able to specifically account for how much, but based on the evidence, we think it might be substantial, actually.
Okay.
Super.
Thank you.
Victoria, thank you very much.
Thank you.